Hi, welcome to this tutorial. So if you see over here, we have a few sides to our EVK. So let's start from this side. We have a USB point where we can basically put our camera or some USB device, for which the firmware basically understands what you have put, so it needs to be compatible. The debug port is USB A to B wire. It needs to be used for that, and the debug ports is going to show you the logs of the LS6, and then this is just a switch, and this is to charge. On the other side, we'll see that there are 4 ports, digital I/O, so D1, D2, D3, D4, and then there is a UART and speaker. There are I2C ports here and servo motor ports. So the servo motor ports are essentially for Dynamixel, but they can be used for any UART application as well. Here there are some power output ports, so we have 12 volts, 5 volts, 3 volts, and on the bottom we have motor driver actuation pins. So these can't be used for very high driving, but they can be used to put on the motor drivers so that we can drive the motor drivers. So there are 4 ports, and there is already a tutorial on how to activate these ports. Over here we have IMU port, analog input port, again servo motor ports, and we have I2C ports. So if we open this box up, what does it look like? So it looks like something like this. So we have the LS5B module over here, but similarly it can also have LS6 module. And just as an example, these 4 ports were the digital I/O ports. So this is where the USB debug and USB and charging port and the switch are. On the bottom there is a lithium-ion battery which is directly connected here. So this is how it looks. This is basically the LS5B module. So this is the actual processor inside. So let's clarify a few things. I2C enabled, so there is actually an I2C chip which will take these analog inputs. The IMU port is again an I2C based port, so you have to use the particular IMU that we are using so that it's more compatible. The UART port is similar to the servo motor ports. It's just that you have access to RX and TX separately over here. And that's pretty much it on this. Now let's try to understand what exactly our EVK does. So let's assume you have your, okay, let's keep it this way. So you have your Android or your PC or any device that you want to control it from, anything, your robot. So here is your robot. Now how do we control it, right? So the link from here to here needs to come via our EVK. Okay, so this is our EVK. Now the link from Android or PC or device can come via Wi-Fi. How internally it works is basically TCP IP. So that's the transfer control protocol. Now once the Wi-Fi is established with the EVK, you can send signals, which in turn can generate more signals. So the EVK, like we talked about, has UART ports, or it has motor driver ports, or it can have GPIO outputs, and all of these things can be used in the similar way that a microcontroller is used for, and these outputs can be taken to the robot. That's how we control the robot. The same way any sensors which are I2C based or have analog inputs, analog outputs on the sensors, or UART based. All of these sensors or modules can in turn give response to the EVK, and the EVK can give it back to your device. So this is the concept of why we use the EVK, and since it's so compatible that you can use any of these, I think it makes it pretty smart and intelligent at the same time. Now the problem time with this take. So approximately just this transmission could take like close to 5 milliseconds. Now even though 5 milliseconds looks like a very small time, but if you really want a more precise control, there is an easier way to go about it. Usually microprocessors are not used for control because processors are not a real-time operating system usually. So what we use is a microcontroller instead. How this would go about is you take your LS6 over here, and through a UART interface we can give a command like go forward, right? So this could be a UART signal. It could be in terms of text, or you can just send one byte as 0, or if you want to go backward you can give 1, and things like that. So you can give a signal in terms of UART or I2C, which in turn is connected to, let's say, a microcontroller. The symbol resembles micro, so this becomes a microcontroller. So this, suppose, is a microcontroller, and it takes the input. Let's say it got the input from LS6, which probably is controlled from your Android device. So your Android device gives a signal to your LS6 key that I want to go forward, and then the LS6 sends a UART forward to your microcontroller, and then the microcontroller is connected to your motor. Now a microcontroller will be very good at controlling this motor because it's really fast, and its only job is to do that. So this actuation can be probably even programmed with a sensor, where, let's say, an obstacle sensor is giving back a reply to the microcontroller to stop the motor. So the microcontroller can stop almost immediately because there's no lag over the Wi-Fi. This is how the interface would usually be when it comes to fast controls. But when it comes to controls where you have around 10 milliseconds to spare, you can actually take the sensor input and send an output directly via LS6, in which case you would not really need a microcontroller in the picture. So this video explained the diversity of all the ports and all the sensors and all the protocols that you can use with EVK, and at the same time it also explains the levels that an EVK is used at. So it's going to be, highest level is going to be here, where the user is going to interact directly via PC or any device. It could be Android device or iOS device or a computer, Windows platform, anything, and then it interacts via the Wi-Fi, and then the signal goes to the EVK, and then from the EVK it goes to the robot might be through a microcontroller, or it could be directly to the actuators or the sensors. Thank you for watching.